In this video, we're going to go over examples 8 and 9. And here's example 8 says, given the tangent alpha equals 8/15th and alpha lies in quadrant 3, find the exact value of the following: sine of alpha over 2, a cosine alpha over 2, and tangent alpha over 2. So here's some steps that explain how to do that. It says given the tangent of an angle and the quadrant, find the exact values of trig functions of half angles. Number one, draw a triangle to represent the given information. Determine the correct half angle formula. Substitute values into the formula based on the triangle and simplify. Okay, so let's apply here. What we have is tangent alpha. So and quadrant 3. Okay, we're gonna, in quadrant 3, both x and y are gonna be negative. So if this is alpha, the opposite is -8. The adjacent is -15. And that gives us the hypotenuse is 15 squared, which is, I think, 225, and 8 squared is 64. And that's going to be a square root of 289, which is going to be 17. All right, so the hypotenuse is 17. So from here, we could find that the cosine alpha is going to be -15 over 17, and the sine alpha is -8 over 17. I don't know if we'll need it, but we have all of the values. Now, let's take a look at where our alpha over 2 is going to be. So if this is our axis of coordinates, and we know that the alpha is in the third quadrant, right? With -8 and -15. So that's where alpha is. Now, where would be alpha over 2? Alpha over 2. Alpha over 2 is half of the alpha, so it's going to be a little bit greater than, just a little bit over the first quadrant. So it's going to be in quadrant 2. So alpha over 2 is going to be between 90 degrees and 180 in quadrant 2. So based on that, we're going to select either positive or negative values from our half angle formulas. Okay, so for question A, we need to figure out sine of alpha divided by 2. And looking at our formulas, we realized that we only needed the cosine. We didn't really need sine unless we want to use sine for tangent, one of these formulas. But cosine alpha is enough. All right, so let's plug in the formula. So since alpha over 2 is in the second quadrant, sine there is going to be positive. So we have positive root of 1 minus cosine alpha, which is -15. -15/17 divided by 2. So let's simplify that. So this is what we're getting. And that is going to be equal to, in the end, after we take a root and rationalize the denominator, we're going to have 4√17/17. Okay, so now what about cosine? Let's do a cosine. So next, cosine of alpha over 2. Again, we're just going to plug in the values into the formula. Formula for the cosine of alpha over 2. And again, knowing that our alpha over 2 is in quadrant 2, we're going to select a negative root. So we have a negative root of 1 plus a -15/17 divided by 2. And again, let's do this algebra. All right, so this is what it's going to look like. And after we go through simplifying everything and rationalizing the denominator, we're going to get a negative root of 17/17. So that's the value of the cosine. Now let's figure out the value of tangent. And again, we're going to apply a formula. Again, all we need is the value of the cosine, and we're going to, and the tangent here in this quadrant is going to be negative. So it's going to be negative root of, and we're going to have like a multi-level fraction. So 1 minus a -15/17 divided by 1 plus -15/17. And the root actually covers this whole thing. So again, let me finish it really quick. So this is the flow of everything. And in the end, we're going to end up with a -4. We could also, for the tangent of alpha over 2, take the value of the sine and divide it by the value of the cosine. So that also would be acceptable. And I would like you to try this problem by yourself. Says given that sine alpha is -4/5 and alpha is in quadrant 4, find the exact value of cosine of alpha over 2. Please pause this video here, and we're gonna continue to our next example. Example 9, which reads, a bicycle ramp is constructed for high-level competition with an angle of theta formed by the ramp and the ground. Another ramp is to be constructed half as steep for novice competition. If tangent alpha equals 5/3 for a higher level competition, what is the measurement of the angle for novice competition? I just wanted to mention that this is what we're talking about. This is the picture that we had at the beginning, the first slide. So this is the ramp for the more experienced competitors, and this is for novice, right? It's twice as not as steep. All right, so let's take a look at this problem. So we have an angle whose tangent is 5/3. So, 3/5, I'm sorry. So this side is 3, this is 5. Okay, so now how long is the hypotenuse? And the hypotenuse is the square root of 9 plus 25. And that is basically square root of 34. Okay, so the cosine of theta is going to be 5/√34. So tangent of theta over 2 is the square root of 1 minus cosine theta. So 5/√34 divided by 1 plus cosine theta, 5/√34. Again, this root covers everything. And theta over 2 is in the first quadrant, so it's going to be positive as well. So let's go ahead and finish this. So I'm going to convert ones into, well, the fractions with the same denominator. Next, I'm going to combine into the same. Into one fraction, the numerator and the denominator. Sorry, you guys don't see. All right, everything. So I'm going to rewrite this multi-level fraction using the division. And then I'm going to apply the rules for division of the fraction. So I'm going to flip them. Flip the second one. And what's going to happen is that we're going to have a similar factor on the top and on the bottom, which will cancel out. All right, so what's next? Well, we have a root of 34 minus 5 divided by root of 34 plus 5 and everything under the root. Okay, so, and I mean, I could rationalize the denominator and do all that, but what I would like to do instead, just basically put this into the calculator. And once I do that, once I put it in the calculator, I'm going to get approximately 0.27698. So I know the tangent of the angle. Can I find out the angle? And the answer is yes. My theta over 2 is going to be the inverse tangent of 0.27698. And when we put this into the calculator, we're gonna get approximately 15.48 degrees. So that's how this problem is done. Now, one may argue that since we're using the calculator anyway, we could do the inverse tangent of 5/3, find theta, and then divide it by 2. Yes, the answer is we could do it that way as well. And that's a much easier and straightforward way to do this problem. But since we did it this way, we practice our identities, and that's how you get to remember them.